So for this question, we have two electromagnetic waves, which are given by the following equations. E1 equals 8.565 sine 2.218 by 10 to the 15 T millivolts per meter, and then the exact same thing for E2, plus a phase difference of 0.4830 millivolts per meter. So for part A, we want to determine the value for E equals E1 plus E2. Okay, so the way that we're going to do that, remember, is to figure out the magnitude. So I'm just going to draw these, and I'm going to draw them at time t equals 0. So that makes it really easy. So this is where our first wave here is. It has a magnitude of 8.565 millivolts, and the next wave, which we add on to the end of it, remember, this phase here is 0.4830, and it also has a magnitude of 8.565. So the way that we add them, remember, from our cosine rule, is going to be 2 E naught, which is going to be our magnitude, and cos a half phi. When we do that, we just shove in all of our numbers. So we have 2.8.565 by cos a half of our 0.4830. Remembering that your calculator has to be in radians, and we get 16.63 millivolts per meter. So that's the answer to part A. Part B, we have to calculate the angle between the resultant vector E and E1. Okay, so this is E1, this is E2, this is E here, and this angle here, this beta angle in here, is the angle that we're trying to calculate. Okay, so we know that beta, for the case of having two electromagnetic waves, it's just a half phi. So therefore it's just a half by 0.4830, and that's going to give us 0.2415 radians. Cool. And then part C is we need to complete the equation. Easy. So then remember our, it's 16.63 millivolts per meter. Sine, now our omega is the same, our angular frequency is the same, so it's at 2.218 by 10 to the 15 T, plus our 0.2415 radians millivolts per meter. And that's it.